All right, guys. Today we're going to be talking about discrete and continuous functions. Remember yesterday we talked about functions, and we know we're dealing with functions when x does not repeat, or we can use the vertical line test. And today we're going to look at discrete versus continuous functions. Okay, so the first thing to note is that this first half here, this goes into your foldable or a foldable, which is attached. But this first part is dealing with discrete right here, and the bottom part is dealing with continuous. So we're going to start right up here with discrete. Okay, a discrete graph is a graph with distinct unconnected points. All right. The description is just say points that are not connected. All right. Another way to describe it is to note that when we're talking about discrete functions or discrete examples or graphs, all right, they're represented only by whole numbers. And then lastly, when we look at examples, the examples are always countable, all right? So the examples are countable. 1, 2, 3, so on and so forth. So what are some examples of things that are discrete? All right, we could talk about people, right? People are discrete because we can't have partial people. Just 1, 2, 3. We can count people in a room. All right. Another example might be pencils or cars, airplanes, calculators, animals. And I'm sure you can come up with way more examples about things that could be countable. All right, so an example of a discrete graph looks like this right here, right? Where there are distinct points. There are 4 points particularly on this graph. And now we're going to look at how do we determine the domain and range. First off, the domain of a discrete graph is a list of all x values. It is a list of all x values. All right. The range of a discrete graph is a list of all y values. So I'm going to use 2 different colors for the domain. Let's say I use blue for domain and red for range, remembering that domain is x, range is y. So when we're looking here at this graph, this is our x-axis. And then this is 0, 1, 2, 3, -1, -2, -3. So when we look at each of our points, 1, 2, 3, and 4, we're going to look for our x values, starting with the leftmost point and going to the right. So here, this first point, the x value is -3. So in our domain, we're going to write -3. And the next one, this point, is -1 for our x, and therefore we're going to write -1. And we're going to continue the same pattern for these next 2 points. And it looks like those x values are 0 and 2. And then we close the bracket and we're done with listing our domain. All right. Notice how the numbers in the domain are countable. 1, 2, 3, and 4. All right. And we're done. All right. Now for the range, we make a set and we go from our bottommost point to the topmost point. So from down to up. All right, down to up. So looking here at this point, right? And always, if you need to, number your number line here. Uh-oh, I just definitely did that backwards. Let's try that again. All right, so that's -1, -2, and -3. And this is +1, 2, and 3. So for our range, all right, this y is -2. The y of the next to the bottom point is -1. And then we look at the y's for our other 2 points. The next y is 0, and the final point has a y coordinate that is 1. And we're done with the domain and range for this example. Now we can move on to a bit more of an example, complex of an example in number 7. It says for each problem, determine the domain and range. I'm going to do 7, you do 8. All right. So if we look at number 7, right, we're still looking for a domain. We'll let that be in blue, right, our x. So we look from left to right. So if we look at this point, our x value is -4. This point, our x value is -3, -2, -1, 0, 1, 2, and 3. And so we're going to write all of that under our domain. And we're done with listing our domain. All right, now we're going to get to the range, which we're going to do in red. All right, remember range is dealing with the y. And we start down at the bottom, and then we go to the points up top. So notice here, our y is -2. For these 2 points here, the y is -1. Here, the y is 1. Here, the y is 2. And finally, these 2 points up here, the y is 3. So we're going to write our domain. Our range. So that is -2, -1. And we only need to write the -1 once, even though there are 2 points that have a range of -1. And then we have 1, we have 2, and 3. And we're done with it. All right, now you try for number 8. Now we're going to move on to talk about continuous functions. All right, when we deal with continuous, a continuous graph is a graph with uncountable connected points. All right, it's uncountable connected points. So, a description of continuous is that we want to make sure we remember the points are connected. All right, that's key. The next thing is, when we talk about continuous function or graph, it's represented by whole numbers as well as fractions or decimals. And when I say in parts, again, that's fractions or decimals. Also, with continuous functions, it doesn't have to be countable. Matter of fact, it's probably not countable. So what are some examples of things that are not countable? Well, got a few things. All right, maybe we're dealing with weight. All right, we can't just count weight, right? So that's one example. Height is another example. Distance is an example. Money, right? Maybe the number of gallons we put in a gas tank. All right, it's not just 1, 2, 3. It's all the stuff in between as well. All right, and lastly, so we're talking about measured things, right? Any type of measured thing is considered to be continuous. So, the domain of a continuous graph starts at the smallest x value and continues to the largest x value. The range of a continuous graph starts at the smallest y value and continues to the biggest y value. So let's look, for example, at these points. We have 2 points on this graph right here, and we're going to go ahead and write the coordinates for those points. All right, some people have a hard time with graphs that don't have the numbers on them, so feel free to put the numbers on them, right, if that's what you need to do. But this point right here, the point is -2, -1 for this point. All right, the point is -2, -1. All right, and for this next one, the point is 2, 2. All right, so we have our points. Now, when we look at the domain, remember we're looking at our x values. So the x value for the leftmost point is -2, and the x value for our rightmost point is 2. So what we're going to write is -2 and put some space in between it and then write 2, right? So we're going from least to greatest. Of course, domain is dealing with x, so we put that in the middle. And then what goes in between, since these are closed intervals, we're going to put less than or equal to. All right? And you don't necessarily have to know what it means. You just have to know that that's how we're going to be writing our domain. So what it means is that our domain x is in between -2 and 2 for this particular graph. Now let's go to range. All right? For our range, we're going to be looking at our y values, right? So looking at the bottom coordinate here, all right, our y is -1. And then here, looking at our top coordinate, right, the y is 2. You may be saying, why are we talking about bottom and top? Because we're dealing with range, which is going up and down, right? So, since it's range, we're going to put y in the middle. And remember, less than or equal to is what we're putting in between. And what this means is that the range y is in between -1 and 2. -1 and 2. So we're going to do the same thing for this next example, number 15 here. We have 2 points. We're going to write what those points are. All right, so this is 1, 2, 3, and then 1, 2, 3. So this point is -3, 3. And this point down here is 1, -4. All right, and I'm going to put that up here so it's out of the way. So now we have our 2 points, right? And if we're looking for domain, we're going to be looking left to right. So our leftmost x value is -3, rightmost x value is 1. Put the x in between and then put in our less than or equal to symbols. This says that our domain for this graph, x, is in between -3 and 1. All right. So now what? Now we're going to deal with our range. Remember, range deals with y. So we're going to look at 3 and -4. -4 is the lowest number. 3 is the highest number. We represent range by y. And don't forget what goes in between is the less than or equal to, denoting that our range y is in between -4 and 3. So we finish with this. Now for the last one. All right, notice that in this graph, there are arrows on the end, and we never pick up our pencil because it continues. The arrows means that it will continue. All right, the arrows means that it will continue. So our domain and range is actually not going to look like the rest of them. Why? Because there is no endpoint, right? Open or closed. There are arrows, which means that this graph will never end. So for our domain, if we're looking at our x's, right, this arrow means that it's going to continue to go down, but also it's going to continue to go left. And then here, it means that the graph will continue to go up, but also right. So the domain here is actually goes from negative infinity to positive infinity. So we just write either all real numbers, or we say negative infinity, that's the infinity sign. And we're going to not say less than or equal to, because the equal to implies